my dear students. Let's start the session.
Right up. Today we are going to start a new topic, that is dynamics of circular motion. First, A, vertical circular motion. Vertical circular motion. Here, vertical circular motion. Vertical circular motion. How to apply dynamics in vertical circular motion? First we can discuss vertical circular motion. After that, horizontal circular motion, conical pendulum problems. Clear? Combination of horizontal and conical pendulum and radius of curvature. Okay. So here vertical circular motion. See this, a particle is in vertical circular motion. Here it is the pivot point. Vertical circular motion. It is the pivot point. Okay, it's a thread or string. Here a point mass is attached. A point mass is attached. This is in vertical circular motion. Here to here, vertical circular motion. Understood? Here the particle at bottommost point. At bottom. First case A. Okay na? Particle or mass is at bottom. At the bottom. At the bottom. Understood? Particle is at the bottom. Draw this figure. Vertical circular motion. Vertical circular motion. Understood? First we need to draw the free body diagram. After that we can apply dynamic equilibrium equations. So what is the first statement? Weight of the element mass always act vertically downward direction. Weight always act vertically downward direction. Tension in the string always pull the body. Tension at bottommost point. Tension always pull the body. This tension pulling this body. This tension pulling this body. Tension in the string always pull the body. Tension in the string. Tension in the string always pull the body. Tension in the string always. Tension in the string always pull the body. Always pull the body. Tension in the string always pull the body. Weight always act vertically downward direction. What is the radial acceleration? Towards the center of circular motion. This is the radial acceleration. Radial acceleration. V square by R. Omega square R. Omega square R. This is the radius. R is the length of the string. R is nothing but length of the string. R is nothing but length of the string. So mg, radial acceleration, so called centripetal acceleration. Radial acceleration or centripetal acceleration. Radial acceleration. We can call it as centripetal acceleration. Centripetal acceleration. Centripetal acceleration. Centrifugal force always act. Centrifugal force. This is the centrifugal force. Mass into radial acceleration. M omega square R. That equal to mv square by R. mv square by R. Clear? So in this case, centrifugal force always act. Centrifugal force always act centrifugal force always act, it always act opposite to the direction of, always act opposite to the direction of, opposite to the direction of, opposite to the direction of radial acceleration. Radial acceleration always act towards the center of circular motion. Centrifugal force, it always act away from the center of circular motion, away from the center of circular motion. It always act away from the center of circular motion. Radial acceleration or centripetal acceleration always act. Centripetal acceleration, it always act. Centripetal acceleration or radial acceleration always act towards the center of circular motion, towards the center of circular motion, towards the center of circular motion. Understood this? Here, radial acceleration, centrifugal force is the inertia force in circular motion. Inertia force in circular motion. Inertia force in circular motion. Inertia force always acts opposite to the direction of acceleration. Radial acceleration. In this case, radial acceleration towards the center of circular motion. Centrifugal force always acts opposite to the direction of radial acceleration. It always acts away from the center of circular motion. When this is the free body diagram. See this free body diagram at bottom. Mass is at bottom. Okay. Free body diagram for the element mass. Free body diagram for the element mass. Radial acceleration towards the center of circular motion. Weight always act vertically downward direction. Centrifugal force FC equals to M into V square by L. M into V square by L. R equal to length of the string. Tension always pull the body. Tension at bottom will be maximum tension. This is the maximum tension at bottom. Minimum tension at the top point. Maximum tension. Inertia force is represented in the free body diagram. Means dynamic problem converted into static problem. We can apply static equilibrium equations. This part completed. Here, radial acceleration, centripetal acceleration always act toward the center of circular motion. Centrifugal force, it always act opposite to the direction of radial acceleration. That means it always act away from the center of circular motion. Inertia force in circular motion is the centrifugal force. Centrifugal force represented in the free body diagram means dynamic problem converted into static problem according to D'Alembert's principle. We generally apply D'Alembert's principle in the dynamics. D'Alembert's principle. Now, apply D'Alembert's principle. D'Alembert's principle. Here we can apply D'Alembert's principle. Apply D'Alembert's principle. D'Alembert's principle. Here, inertia force represented in the free body diagram. Here, inertia force or centrifugal force is centrifugal force represents in the free body diagram. Represents in the free body diagram. In the free body diagram means it means dynamic problem converted into static problem. Dynamic problem converted into, actually the given question is dynamic problem or static problem. Vertical circular motion is what? Dynamic problem. So we represented inertia force in the free body diagram means what? Dynamic problem converted into dynamic problem converted into dynamic problem converted into dynamic problem converted into static problem. Static problem. So that is the D'Alembert's principle. First represent inertia force in the free body diagram. Then apply static equilibrium equations. Apply static equilibrium equations. Static equilibrium equation. Apply static equilibrium equation. Sigma Fy equal to 0. Sigma Fy equal to 0. That means what? Sum of the upward force equal to sum of the downward forces. Then what you will get? Sum of the upward force equal to how much? T maximum equals to mg plus fc. So we can write T maximum equals to mg plus m omega square L, or else you can write mg plus mv square by L. Here R equal to L. R is the radius of circular motion. Okay na? Circular motion of the point mass. L is the length of the string. You can write m into g plus v square by L. M into g plus v square by L. T maximum, you can confidently write it as m into g plus v square by L. This is the maximum tension in the string that is obtained at bottom point in the vertical circular motion. Completed. This part done. Maximum tension. Now continuation to this, connection in the mechanical properties of solids. What is the maximum stress induced in the string in vertical circular motion? This part done. Right off. Here in vertical circular motion. Now we need to calculate. This is the maximum tension calculations. Maximum tension. Why it is maximum tension? Plus will come. At the top point, minus will come. This is the maximum. That would be minimum. Clear? So now this part done. Now we can write. Now we need to calculate. We need to derive the expression for maximum stress induced. This is maximum stress induced. Maximum stress induced in the string. What is the maximum stress induced in the string? This is at bottom point. This is at the bottom. It is at the bottom point. Minimum stress induced in the string at the top, when the point mass is at top point. For that, in order to calculate the stress, we need to apply Hooke's law. In order to calculate the stress, apply Hooke's law. apply. Here, stress you can directly get it. Sigma maximum can be written as T maximum by corresponding area of cross section. T maximum by stress, internal resistance offered by the body. This is the maximum stress induced in the string by area of cross section of the string. 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 T maximum equal to how much? It is at bottom position. T bottom by T bottom, that is maximum, the A, that equal to how much? M into G plus V square by length of the string by how much? Area A. Understood? That is the maximum. T maximum is this. T maximum is this. This is the maximum stress induced in the string. Maximum stress induced in the string at bottom point, when the point mass is at bottom. This is the maximum tension in the string obtained at bottom. Maximum stress, corresponding stress will be maximum. T maximum is the internal resistance offered by the body per unit area of cross section. Next slide now, completed. What is the maximum elongation in the string? What is the maximum delta L? What is the maximum elongation in the string? Delta L maximum. Delta L maximum. This is the maximum elongation in the string. 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 That is obtained at bottom. At bottom point. At bottom point. How to calculate delta L maximum? For that we need to apply Hooke's law. Apply Hooke's law. What is Hooke's law? Tell me. Apply Hooke's law. Apply Hooke's law. What is Hooke's law? Longitudinal stress directly proportional to longitudinal strain. Longitudinal stress directly proportional to longitudinal strain. So remove the proportionality. Introduce the proportionality constant Young's modulus. Okay, so what is the sigma L? Sigma L. In this case, sigma maximum is obtained. Sigma maximum is obtained at bottom. That is nothing but delta L maximum. Elongation by original length of the string. Original length of the string. Here you can write it as T maximum by corresponding area of the string. Delta L maximum by L. So from here you can apply, you can get delta L maximum elongation in the string. Maximum elongation in the string equal to T maximum into L by AY. AY is the axial rigidity. T maximum. What is the delta L maximum? Tell me. Delta L maximum, tell me. Maximum tension. Entire discussion is at the bottom point. So here what is obtained? Tell me. T maximum. How much is obtained? mg plus m into g plus v square by L into L by how much? AY. By how much? AY. Are you clear? Understood? So here what you will get? Tell me. mgl. M into GL plus V square by AY. M into GL plus V square that is the maximum elongation in the string. This is the way to apply dynamics at bottommost point when the particle is in vertical circular motion. Now coming to the topmost point, when the point mass is at top, point mass is at top. Completed. So now tell me, we need to draw free body diagram when the point mass is at top, topmost point. Okay now, so here vertical circular motion, vertical circular motion. Here you can directly apply. Why? Because we know how to draw free body diagram. See here, vertical circular motion at topmost point. So here we need to apply dynamics when the point mass is at topmost point at top. Clear? So this is the point mass is at top. Point mass is at top. Here to here. Point mass is at top. So understood. So here, if you see from the top, vertical circular motion, we need to see from the side. So here to here, the point mass is here. This is the point mass. Point mass here. Okay, it is rotating in this particular direction. If omega, this would be V. V equal to R omega. V equal to R omega. Understood? So now apply dynamics. Apply dynamics. Weight always at. Weight always at. mg always at vertically downward direction. Tension always pull the body. You can take top. That is top with the bottom. This you can take top T. You can take A. So what is the tension when the pen is at top? Tension always pull the body. Tension always pull the body. So radial acceleration always at towards the center of circular motion. Centrifugal force always at opposite to the direction of radial acceleration. Mass into radial acceleration, that equal to how much? M into V square by R. That equal to M into V square by L. M into V square by L. So now we can draw separately free body diagram at top point, yet topmost point, at top point, at the top. At the top, what is the free body diagram for point mass? This is the free body diagram for point mass. Radial acceleration always at towards the center of circular motion. Weight always at vertically downward direction. Weight always at vertically downward direction. Tension, this tension is minimum tension. This is the minimum tension. Centrifugal force. Centrifugal force always at away from the center of circular motion. Centrifugal force mv square by L. mv square by L. A radius of circular motion equal to length of the string. Length of the string mv square by L. This would be R, radius of circular motion. Understood? So inertia force represented, centrifugal force is nothing but inertia force in circular motion. Inertia force is represented in the free body diagram means what? Dynamic problem converted into static problem. Apply static equilibrium equations. Sum of the upward force equal to sum of the downward forces. Sigma Fy equals to 0. Then what you will get? Sum of the upward force equal to downward force is nothing but T minimum plus mg. T minimum plus mg equals to centrifugal force. T minimum equals to centrifugal force minus mg. So we can write T minimum is nothing but mv square by L minus mg. Then T minimum can be written as m into v square by L minus g. v square by L minus g. That is the T minimum. That is obtained at the topmost point. Clear? Next, completed. What is the corresponding minimum stress induced? What is the corresponding minimum stress induced? Minimum stress induced in the string. Minimum stress induced in the string. So minimum stress induced when the point mass is at topmost point. Sigma minimum is the stress induced. That is the T minimum by corresponding area. So then sigma minimum equal to how much? M into V square by L minus G by how much? Area A. This is at topmost point. Okay na? Vertical circular motion at topmost point. At the top point. Understood? Vertical circular motion at the top point. This part, this is the free body diagram. Corresponding minimum tension, y minimum. Minus is coming here, that is minimum. Minimum stress induced. What is the minimum elongation? In the string? Minimum elongation, delta L. Minimum elongation in the string. Minimum elongation in the string. What is the minimum elongation in the string? We already know that. Hooke's law. This is how much? Sigma minimum equal to how much? Y into delta L minimum by. This is the longitudinal stress, longitudinal strain. Change in dimensions by original dimension is nothing but longitudinal strain. So then what you will get? Tell me. T minimum by area equal to how much? Y by L into delta L minimum. Delta L minimum equal to how much? Minimum elongation equal to how much? T minimum into L by AY. What is the T minimum? M into V square by L minus G into L by AY. Delta L minimum. This is the delta L minimum. So if you simplify a little, then what you will get? Tell me. Delta L minimum, what is obtained? Delta L minimum equal to how much? M V square minus GL by AY. Delta L minimum equal to M into V square minus GL by AY. This is the minimum stress induced at topmost point. This is the minimum elongation corresponding minimum strain, minimum tension. Okay na? Same thing is obtained. Similar kind of discussion is at the bottommost point. At bottommost point, T maximum is obtained. In that case, plus will come. Clear? This is the some funda related to vertical circular motion. Procedure to draw free body diagram for the point mass at bottommost point and topmost point. Completed. Next, horizontal circular motion. Horizontal circular motion. This is vertical circular motion. Horizontal circular motion means no effect of gravity. Horizontal circular motion means no effect of gravity. See this. Horizontal, case B. Write down case B. Case B. Horizontal circular motion. Horizontal circular motion. Horizontal circular motion. How to apply dynamics in horizontal circular motion? See here, this is the pivot point. Pivot point. So this is the point mass. Point mass M. Point mass M. Point mass M. You can take this part, circular motion. Horizontal circular motion. Understood or not? So here no effect of gravity. If you see from the top, what is the top view of it? See from the top. Here to here. This is the point mass. This would be omega. This would be V. R. If it is rotating like this, V equal to R omega. This is the point mass. If you see from the top, it look like this only. Understood? So now tell me. Now tell me. Draw decent figure. Horizontal circular motion. Clear? So same story. Weight always at mg. Always at vertically downward direction. Tension always pull the body. Tension always pull the body. Radial acceleration always at towards the center of circular motion. Centrifugal force always at opposite to the direction of radial acceleration. Clear? So if you draw free body diagram for either right or left, doesn't matter. Both are same. No effect of gravity. No effect of gravity. That is the assumption. No effect of gravity. Okay, now then only it will move horizontally. This force is not balanced by any other force. Understood now? That means no effect of gravity. So if you draw free body diagram comfortably, free body diagram for this point mass, radial acceleration towards the center of circular motion, then tension in the string. This is the tension in the string. So here this is centrifugal force mv square by L or else m omega square L. R is equal to radius of circular motion equal to length of the string. Here you can write it as m omega square R. That equal to mv square by R. That is equal to centrifugal force equal to mv square by L. mv square by L. So inertia force represented in the free body diagram means dynamic problem converted into static problem. You can apply static equilibrium equations. Sigma Fy equal to sigma Fx equals to 0. Sum of the left force equal to sum of the right forces. Tension. This is the tension. mv square by L. Tension T equals to mv square by L. We can write it as m omega square L. This will be minimum and maximum both. Only one tension obtained. Yet left and right, both will be same. Both will be same. Even if you draw free body diagram, when the point mass is at left end, centrifugal force acting This is the radial acceleration. Weight acting vertically downward direction. Tension always pull the body. Tension always pull the body. Next, centrifugal force. Always act away from the center of circular motion. Then we can confidently say that at left hand and right hand, at left hand, at left hand, at left hand, at right hand, at right hand. So at left and right hand. So here, what is the free body diagram at this point? You will get the same. You will get the same. So here, no effect of gravity. No effect of gravity. Tension. This would be centrifugal force. mv square by L. So here it is A point, B point if you take. So this will become TA, this will become TB, this will become TB, TB. Left to right, left to right, whatever it is. TA equal to TB equal to how much? This is TA. TA equal to TB equal to how much? Confidently tell me. TA equals to TB equals to mv square by L. Or else m omega square L. M omega square L. Are you following or not? Same string, same tension. Okay. So at right and left, you will get the same kind of free body diagram. This tension balanced by centrifugal force. This tension balanced by centrifugal force. At left and right hand, in horizontal circular motion, no effect of gravity, completed. Now we need to talk about one special case. In horizontal circular motion, put a note. It's a one question. So if they give like this, focus here. Now we need to take 2 point masses M1 and M2. 2 point masses M1 and M2. Focus here. This is the pivot. This is the pivot. Here to here. This is the point mass. Point mass M2. Length L. Length L. This would be L. After that, the string is different. This string is different. This mass is M1. This mass is M1. Length would be L. Length would be L. Length would be L. Horizontal circular motion. Here to here. Horizontal circular motion. So here, what is the omega? See this, it is rotating along this direction. This is omega. Understood? See this? You can draw one circle. This is the another circle. 2 circles required. In the topmost, from the top you can see. From the top you can see. This is M2. This is M2. This is M2. This would be M1. M1. If you rotate like this, this is omega. L. Clear? So what is the velocity at point? This is 1. This is the velocity. Velocity at point 1, tell me. What is the velocity at point 1? R1 into omega. R1 into omega. What is R1, tell me? 2 times of L into omega. 2 times of L into omega. What is the velocity V2? What is the velocity V2? R2 into omega. Omega R2. Then what we will get? L omega or omega L. Understood? So this is the mass 2 and mass M1. mass 2 and mass m1. See here. So here, in this case, what people are getting? Radial acceleration always act towards the center of circular motion. Clear up? So tension in the string. Tension in the string. This is the string 1. This is the string 1. String 1. This is the string 2. Tension in the string 2. This is the tension in the string 1. T1. Tension in the string 1. T1. M1G neglected. M1G neglected. M1G neglected. See here. This is how much centrifugal force acting on the mass 1. Okay now, that is nothing but mass into radial acceleration of the point mass. So now you can get Fc1 equivalents to m omega square into r1. M omega square into r1. R1 equal to how much? R1 equal to how much? 2L. So Fc1 can be written as, tell me, 2 times of m omega square L. 2 times of m omega square L. 2 times of m omega square L. Take this. Draw free body diagram for point mass m1. Draw free body diagram for point mass m1. This would be how much? Tension T1. This would be tension T1. This is M1, M1, M1. Understood or not? M1, T1. That is equal to how much? Fc1. Fc1 equal to 2 times of M1 into omega square L. 2 times of M1 into omega square L. We can confidently write T1 equal to how much? 2 times of m1 into omega square L. Are you getting the same? Are you getting the same? If you draw free body diagram for mass m2, free body diagram for mass m2, radial acceleration always act towards the center of circular motion. Tension, this is the tension in the string. This would be T2, this would be T2. Same string, same tension. Different string, different tension. Clear up? So now tell me, tension always pull the body. That is T1. That is T1. Centrifugal force acting on this. Centrifugal force acting on this. Fc2 equal to how much? M2 omega square R2. M2 omega square R2. R2 equal to how much? L. So if you draw free body diagram, for this, draw free body diagram for mass m1. Draw free body diagram for mass m1. So this is how much? Tension T2. This tension T2 will be acting. Tension in the string 2 will be acting here. So tension T1. This would be tension T1. So this would be centrifugal force acting on the mass. This is M1. This is M2. This is M1 and M2. Understood or not? Centrifugal force. M2. Centrifugal force equal to how much? M2 omega square L. M2 omega square L. What is the tension T1? What is the tension T1? 2M1 omega square L. 2M1 omega square L. Sum of the left force equal to sum of the right forces. Then what we will get? T2 can be written as Fc2 plus or else T1 plus Fc2. T1 plus sum of the left force equal to sum of the right forces. T2 can be written as T1 equal to how much? 2M1 omega square L plus m2 into omega square L. That equals to, you can write confidently that, we can write confidently 2m1 plus m2 into 2m1 plus m2 into omega square L. Okay, so here finally we can write what is the T1 and T2 obtained here. Finally, what is the final answer or result? What is the final result? Tell me. T1 equal to how much? What is T1? Here, what is T1? T1, T2 and T1 by T2 or T2 by T1. So what is T1? Tell me. T1 equal to how much? 2m1 omega square L. What is T2? 2m1 plus m2 into 2m1 plus m2 into omega square L. T2 by T1 can be written as, so here omega square L gets cancelled out. 2m1 plus m2 by 2m1, m1 plus m2 by 2m1. This is the final answer to this question. Here T2 by T1, T2 by T1. Understood or not? Understood or not? So here we applied free body diagram. M1 omega square R1 equal to 2L. So 2m1 omega square L, 2m1 omega square L, 2m1 omega square L, m2 omega square L, 2m1 plus m2 into omega square L. So T1 and T2 obtained. Finally T2 by T1. Next item, conical pendulum. Completed. Conical pendulum. How to apply dynamics? Dynamics of conical pendulum. Or dynamics in conical pendulum. Focus here. Conical pendulum. Dynamics in conical pendulum. Dynamics in conical pendulum. Dynamics in conical pendulum. How many pendulums in the syllabus? Simple pendulum, compound pendulum, conical pendulum. So how to apply dynamics in conical pendulum? How to apply dynamics in conical pendulum? This is the pivot point O. Pivot point O. See here, point mass. This is the point mass. M is the point mass. Understood? See here, it follows the circular path. This point follows the circular path. It gives the chord. Understood? It follows the circular path. Understood or not? Here to here. It follows it's a chord. It looks like a chord. Understood? So it follows the circular path. Simple pendulum means like this it will oscillate. Like this it will oscillate. Clear? Conical pendulum. It follows circular path. Understood? So wait always at. Draw free body diagram. Wait always at. Vertically downward direction. This would be theta. Theta should be measured from the vertical. So here to here. This would be theta. Tension always pull the body. This tension pulling this body. Understood? Centrifugal force. This is the radial acceleration. Always act towards the center of circular motion. Radial acceleration. Always act towards the center of circular motion. Then centrifugal force always act. Centrifugal force always act opposite to the direction of radial acceleration or away from the center of circular motion. So we can resolve the tension. What you will get, tell me? T cos theta vertical, T sin theta horizontal. Okay na? T cos theta vertical, T sin theta horizontal. Draw, recreate this. Here to here, we are discussing circular motion. We are interested in circular motion. Here to here. Draw free body diagram for this. Point mass. Free body diagram for the mass. FBD. FBD for the mass M. FBD for the mass M. Understood? So here, length of the string L. L is the length of the string. R is the radius of circular motion. Radius of circular motion. From here, sin theta equivalents to how much? R by L. R by L. This is how much? R square. This is L square minus L square minus R square. L square minus R square. Clear? So now tell me, what is the free body diagram for the point mass? What is the free body diagram for the point mass? Here, what is happening here? What's happening here? Tension T. This is the tension T. Here to here. This would be theta. So now T cos theta. This is T cos theta. This would be T sin theta. T sin theta. Weight acting vertically downward direction. Weight acting vertically downward direction. Radial acceleration along this direction. Centrifugal force. Centrifugal force equal to M omega square R. M omega square R. In this case, R is not equal to length of the string. Okay, so now we can apply static equilibrium equations because centrifugal force represented in the free body diagram. Sigma Fx equal to 0, sigma Fy equal to 0. Focus here. What is sigma Fx equal to 0 and sigma Fy equal to 0? What you will get, tell me? If you apply sigma Fx equal to 0, what is obtained? Sigma Fx equal to 0. Sigma Fx equal to 0. Sum of the left force equal to sum of the right forces. Then what is obtained? T sin theta. T sin theta equals to centrifugal force. T sin theta can be written as M omega square R. M omega square R. M omega square R. That equal to M V square by R. M V square by R. Understood? So what about sigma Fy equal to 0? Sum of the upward force equal to sum of the downward forces. Sigma Fy equal to 0. First you should know how to draw free body diagram properly. Sum of the upward force equal to sum of the downward forces. Then T cos theta can be written as mg. Sum of the upward force equal to sum of the downward force. So this is equation number 1, equation number 2. This would be equation number 1. Equation number 1, equation number 2. Equation number 1 and equation number 2. Now 1 by 2 you can make it. 1 by 2. What is obtained, tell me? 1 by 2. If you write 1 by 2, T sin theta by T sin theta by T cos theta. T sin theta by T cos theta equal to M V square by R. mv square by r. By how much? mg. By how much? mg. Gets cancelled out. V square by rg. V square by rg. Tan theta equals to V square by rg. Tan theta equals to V square by rg. What is the velocity here? If they ask velocity V, square root of rg tan theta. Rg tan theta. Are you clear? This is how much? Rg tan theta. V equal to Rg tan theta. What is tan theta here? What is tan theta here? Tan theta here. R by square root of L square minus R square. Tan theta equal to how much? Tan theta equal to how much? Tan theta equal to how much? R by. So here we can write tan theta equals to 1 by square root of L square by R square minus 1. 1 by square root of L square by R square minus 1. L square by R square minus 1. If you substitute that part here, what is obtained? Velocity V. What is obtained? Tell me. Square root of Rg by square root of Rg by square root of L square by R square minus 1. Understood? Rg tan theta equal to 1 by L square by R square minus 1. Tan theta equal to this. Tan theta equal to this. Clear? So T sin theta, what is the tension? Completed. This part done. Now T sin theta equals to tension T. How to calculate tension T here? If they are interested in tension in the string, tension in the string. So T sin theta equal to R by R. T sin theta equal to mv square by R. R m omega square R. So T sin theta can be written as R by L. That equal to m omega square R. Tension T equal to, confidently tell me, m omega square L. M omega square L. This is the tension in the string. M omega square L. V is the circular motion velocity. If you see from the top, here it would be omega. V equal to how much? So this is the V. V equal to how much? R omega. V equal to how much? R omega. That V calculated. That V equal to how much? Square root of Rg tan theta. Square root of Rg tan theta. Clear? Completed. Next, this is the dynamics in conical pendula. Next, the combination of these two. Focus here. here. This is the pivot point. Okay, so we can call it as one kind of pulley. We can make it. You can kind of pulley here to here. Okay, so it is on the horizontal plane. It is on the horizontal plane. The mass is on the mass M1. Visualize the case. Mass M1 is on the horizontal plane. So here same string, same tension. Same string, same tension. This would be mass M2. Mass M2. This would be length L1. This would be length L2. This would be length L2. Here to here. Here to here. It's a conical pendulum. Conical pendulum. Horizontal circular motion combination. The combination of horizontal circular motion as well as like this, here to here. This. How to visualize this case? Entire discussion is bottom of the here below the table, verticals with this conical pendulum. Now are you able to feel this? Are you able to feel this? ఈ మార్కర్ చూడండి. Understood or not? It follows horizontal circular motion. It follows horizontal circular motion. So this I can see that here to here. It is on this. Here it is moving like this. So here to here. This is omega 1. Here it is how much? This would be omega 2. This would be omega 2. Clear? Understood or not? So here omega 1. So tension in the string would be same string, same tension. Here it is moving like this. Here it is moving like this. Understood? So this part is moving like this. This part follows the conical pendulum. So now tell me, what is the tension T? Tension always pull the body T1 equal to T. This is a T1. This is T1. Radial acceleration towards the center of circular motion. Centrifugal force always act away from the center of circular motion. M omega 1 square R1. R1 equal to how much? M omega 1 square into L1. M omega 1 square into L1. Very clear? So now tell me, this is the tension T2. Tension T2. This is the tension T2. Tension T1. So pulley is frictionless pulley. Frictionless. So T1 equivalents to T2. T1 equal to T2 equal to T. T1 equal to T2 equal to T. Clear up? So if it is theta, then what is uptime? If it is theta, so tension is how much? This is theta. T2 cos theta. T2 sin theta. T2 sin theta is balanced by This is R2. Centrifugal force. Centrifugal force always act away from the center of circular motion. FC2 can be written as M2 omega 2 square R2. M2 omega 2 square R2. So FC2 equal to how much? M2, yeah, that's it. Omega 2 square R2. So now tell me, what is the sin theta here? Sin theta here, R2 by L2. R2 by L2. Understood? So how many free body diagrams here? For point mass, M1. Here it is M1. For M1, what is the free body diagram? Tension T. This would be tension T. Same string, same tension. Here it is how much? FC1 equal to how much? M1. This is M1. M1 omega 1 square. M1 omega 1 square. L1. Radial acceleration towards the center of circular motion. Clear? So what is T? Tell me here from this. T tell me M1 omega 1 square L1 omega 1 square L1 T equal to M1 omega square L1. So here what is obtained? For mass M2, what is obtained? Tension T. This is the tension T. This is the tension T. Theta. T cos theta. T cos theta. T sin theta. T sin theta. Along with that, this is mass M2. FC2 is nothing but M2 omega 2 square R2. Omega 2 square R2. Weight acting vertically downward direction. Weight always act vertically downward direction. Weight always act. This is M2G. Weight always act vertically downward direction. This is M2G. Now coming to T sin theta equal to how much? T sin theta equal to how much? M2 omega 2 square R2. M2 omega 2 square R2. Sin theta equal to how much? R2 by L2. M2 omega 2 square L2. So finally T equal to how much? This is R2. R2 gets cancelled out. T, you can confidently write M2 omega 2 square L2. M2 omega 2 square L2. Clear up? So this is equation number 1. This would be equation number 2. We applied dynamics for horizontal circular motion, and then we applied dynamics for conical pendulum. Okay na? From here tension T, both the tensions are same. Okay, strictly speaking, this is the tension T1. This would be tension T2. Tension T1 and T2. Here both are having same tensions. Clear up? T1 by T2. So here T1 equal to T2. T1 equal to T2 equal to T. So now we can confidently write. M1 omega 1 square L1 equals to M2 omega 2 square L2. Then L1 by L2 equal to how much? m2 by m1 into how much? Omega 2 by omega 1 whole square. This is the final answer to this question. This is the final expression in terms of length. L1 by L2 equal to m2 by m1 into omega 2 by omega 1 whole square. Clear? If m1 equal to m2 equal to m1 equal to m2 equal to m1 equal to m2 equal to L1 by L2 can be, what is L1 by L2? Omega 2 by omega 1 whole square. Omega 2 by omega 1 whole square.
mark करें. Easy fill.
Clear or not? First you have drawn free body diagram. So this is the here up to here free body diagram for this is FBD for mass M1. This is FBD for mass M2. Same string here. This may be T1. This you can write T2, that is also T. T1 equal to T2 equal to this. Clear? So this is the way to apply equilibrium equations. Corresponding equilibrium equations. Solving these two equations. Understood or not? You have drawn free body diagram properly. First, analysis of horizontal circular motion. This is conical pendulum. Horizontal circular motion, conical pendulum. From conical pendulum, tension T2 is obtained, but actually T1 equal to T2. Tension T1 equal to T2. Are you able to visualize this? It is able to move along this direction. So this is moving along this direction. Clear? This is the conical pendulum. Horizontal circular motion. M1 follows horizontal circular motion. M2 follows conical pendulum. Here it is a circular motion. Angular velocity is how much here? Omega 2. What is the angular velocity here? Omega 1. So drawn free body diagram for current. This is M2, M1, M2. This is mass M1, mass M2, M1, M2. So finally what is obtained? L1 by L2 equal to M2 by M1 into omega 2 by omega 1 whole square. Completed. Next, this is the dynamics in conical pendulum. Dynamics in conical pendulum. So now we need to analyze another situation. Focus here. Now we can see one situation, analyze it. Here, this is the vertical. Here, the person. Here. So the person is here. It is rotating. This part is rotating. This is rotating with angular velocity omega. Rotating with angular velocity omega. Okay? So a person is here. A person is here. Okay, now a person is here. Understood? A person is on the vertical surface. We need to draw free body diagram for this particular person. You can see this. Here, this guy is here. Understood? Entire, this is the circular one. It is rotating, 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 rotating. Understood? So now, here, the person is here. What is the kinematics part of it? Here to here, this is omega. Here the person is here. Person is here. This is the radius. What is the velocity V? R omega. R omega. Weight of the person. Weight of the person always at. Weight of this person always at vertically downward direction. Okay. Frictional force. What is helping? Which force is helping here? Frictional force is helping. This guy is not on the ground. Okay. He stick to the vertical surface. Vertical wall. Walls of the cylinder. Which force is helping? Frictional force. Frictional force equal to mu into N. Frictional force. Maximum frictional force is mu into N. F maximum. This is the maximum frictional force. That is mu into N. So here at this particular, if you take the circular motion of this person, circular motion, this is the center of the circular motion. Radial acceleration acting towards the center. At this point of contact, normal reaction will be acting perpendicular to the surface. Centrifugal force is acting away from the center of circular motion. mv square by r. mv square by r. So if you draw free body diagram, at every point of contact, two normal reactions will be acting. Both are equal in magnitude and unlike in nature. At that point of contact, vertical surface, this is the point of contact. One normal reaction is acting on the vertical wall. Another normal reaction is acting. Another normal reaction is acting on this person. Another normal reaction is acting on this person. Understood? This is the normal reaction business. Are you clear? Centrifugal force is acting away from the center of circular motion. That is mv square by r. Weight acting vertically downward direction. Weight acting vertically downward direction. Okay, now frictional force is acting. He is able to slide down. He is about to slip down. Okay, now frictional force always act opposite to the direction of motion. Opposite to the direction of motion. Frictional force. This is the frictional force. Relative friction. This is the concept of relative friction. Frictional force will be acting. So one frictional force is acting on this surface, another frictional force will be acting on the vertical wall. This is vertical wall of the cylinder. Wall of the cylinder. So here this is the person. Free body diagram for vertical wall. For vertical wall, at every point of contact, whatever it is, at point of contact, two normal reactions will be acting. One will be acting on the person, another one will be acting on the wall. He is able to slide down or moving up. He is able to slide down. That means weight acting vertically downward direction, of course. He is able to slip down. Then frictional force always act opposite to the direction. Clear up? But he is not actually slipping. Understood? So here, what is the FF maximum? Mu n. Mu n. Understood? So finally, what is the free body diagram for this person? Free body diagram for this person. Sum of the upward force equal to sum of the downward forces. What will get me? Sum of the left force. sigma fx equal to 0. Sum of the left force equal to sum of the right forces. N equal to how much is obtained? N equal to how much? Centrifugal force. N equal to how much? mv square by r. mv square by r. Frictional force less than or equal to ff maximum. Maximum frictional force is this. Clear up? So here this is how much? Frictional force here how much? mg less than or equal to mu into n. Mu into n. mg equal to less than or equal to n equal to how much? Mu into mv square by r. mv square by r. Here how much? mg mm gets cancelled out. rg less than or equal to mu into v square. Correct? Okay, given data only. So here v square greater than or equal to rg by mu. So v greater than or equal to square root of rg by mu. Okay, now v greater than or equal to, what is the v greater than or equal to? Tell me. Finally, v greater than or equal to square root of rg by mu. Understood? This part is clear. This part understood. Frictional force must be less than or equal to maximum. What is the maximum? This is the limiting friction. What is the limiting friction condition? Ff maximum equal to mu L. Ff is balanced by whom? Mg. Mg must be less than or equal to mu n. N is what is obtained n? mv square by r. Mm gets cancelled out. Rg is less than or equal to mu into v square. Then finally what is obtained? V must be greater than or equal to square root of rg by mu. He has to maintain more than v. Then only the person will stick to the wall without slipping down. He has to maintain this much minimum v we need to maintain. Understood? So minimum this much velocity we need to maintain in order to avoid the slipping of the person down. Clear? Then only he will stick to the walls of the cylinder. Otherwise he will fall down. Understood? Here we need to cover both friction as well as this friction as well as centrifugal force. Okay, this force is pulling this person towards left. This frictional force is helping. Understood? He is pulling upward. Understood? These two forces helping the person without slipping down. Understood? That is why he is able to stick to the walls of the cylinder. But he has to maintain minimum this much velocity. This is the velocity. Are you following? Understood or not? Understood or not? మీరు సర్కస్ చూసుంటారు కదా, జుప్పుని వెళ్ళిపోతాయి. అర్థమైందా? అది కూడా సర్కులర్ మోషన్. అర్థమైందా? ఇట్లా పోయి ఇట్లా వచ్చేస్తాడు. అర్థమైందా? సో వాడు మినిమం వెలాసిటీ మెయింటైన్ చేయాలి, లేకపోతే పడిపోతాడు. అంతే కదా? ఆ బైక్ ఉంది కదా, ఆ బైక్ ఇట్లొచ్చి జుప్పుని పోవాలి. అప్పుడు వెయిట్ ఆఫ్ ద బైక్ కిందకు ఉంటుంది. సెంట్రిఫ్యూగల్ ఫోర్సెస్ ఇటు ఉంటాయి, ఫ్రిక్షనల్ ఫోర్స్ పైకి ఉంటుంది. అర్థమైందా? లేకపోతే వాడు కింద పడిపోతాడు. క్లియర్ అన్న? దట్ ఈస్ ఎంటైర్ స్టోరీ. ఇక్కడ వీడైతే ఏమి తిరగట్లే, గమ్ముడు. ఇది మామూలుగా సర్కస్లో ఎలా ఉంటుంది, పర్సన్ ఏమో బైక్ వేసుకొని తిరుగుతూ ఉంటాడు. ఇక్కడ కేసు ఏంది, ఈ పర్సన్ ఏమో గమ్ముగా ఉంటాడు. అర్థమైందా? ఈ సిలిండర్ ఇట్స్ రొటేటింగ్ అనమాట. అర్థమైందా? సిలిండర్ రొటేట్ అవుతుంది. సిలిండర్ ఈజ్ రొటేటింగ్. దిస్ పర్సన్ ఈజ్ ఇన్ ద సర్క్యులర్ మోషన్. ఓకేనా? సిలిండర్ ఏమో రోటరీ మోషన్, ఈ పర్సన్ ఏమో సర్క్యులర్ మోషన్. ఇన్ దట్ కేస్ వీ నీడ్ టు కన్సిడర్ ద పర్సన్ యాజ్ ఏ పార్టికల్. అండర్స్టూడా? కంప్లీటెడ్. సో నువ్వు దాన్ని అప్లై చేసినా అదే వస్తుంది. ఒక బైక్ ఎత్తుకో, అప్లై కావాలంటే వాడే తిరుగుతుంది అనుకో, వాడు తిరిగి సిలిండర్ ఏమో స్టేషనరీగా ఉంటే బాగేది అంటారు కదా సర్కస్లో అది దానికి కూడా సేమే వస్తుంది. సేమ్ అనాలిసిస్, రెండు ఒకటే కేసు అసలు. క్లియరా? సో ఇప్పుడు నీకు ఒక బావి లాంటిది ఒకటి ఎత్తుకో, ఆ సర్కస్ కేసు మొత్తం డైనమిక్స్ అప్లైది, ఆ సర్కస్ కి డైనమిక్స్ అప్లైది. సో కింద ఉంటుంది వీడు బైక్ ఎత్తుకో, ఇట్లా బైక్ ఉంటుంది, ఇట్లా కిందకి రాదు. సో నువ్వు ఈ వ్యూలో చూడాలి, ఈ వ్యూలో చూడాలి. బైక్ కారు ఏదో. సో బైక్ కారు సర్క్యులర్ మోషన్. టాప్ వ్యూలో చూస్తే నీకు సర్క్యులర్ మోషన్ కనిపిస్తుంది. క్లియరా? సో ఇట్లా ఉంటుంది కారు, ఇట్లా ఇట్లా ఉండాలి, టైర్లు ఇటు పక్కన ఉండాలి. క్లియరా? టైర్లు ఇటు పక్కన ఉండాలి. సో ఇట్లా పోయి ఇట్లా వచ్చి ఇట్లా వచ్చి ఇట్లా రావాలి. దిస్ ఇస్ ద కార్. ఓకే? సో నువ్వు టాప్ నుంచి చూస్తే కార్ కనిపిస్తుందా? టాప్ నుంచి చూస్తే సైడ్ వ్యూ కనిపిస్తుంది, ఇట్టే సైడ్ కనిపిస్తుంది, అంతే కదా? సో వాడు ఇటు తిరుగుతున్నాడు, ఎట్టగట్ట తిరుగుతున్నాడు, ఇటు తిరుగుతున్నాను ఒమేగా, ఇట్లా V = R⍵ వస్తుంది. V = R⍵ వస్తుంది. క్లియరా? సో ఇప్పుడు నీకు ఇది పెద్దదే కాబట్టి క్యాపిటల్ R తీసుకో, పెద్దది కదా ఇది, క్యాపిటల్ R⍵ తీసుకుంటే అప్పుడు నీకు కారే తీసుకో. క్లియరా? సో హియర్ టు హియర్ దిస్ ఈజ్ ద కారు, here to here this is the car. Understood? ఇదో ఇట్లా వచ్చి ఇట్లా పోతాడు. క్లియర్? సో దిస్ guy is in the circular motion. Entire part is what? Circular motion. Circular motion. Are you able to visualize this? Are you able to visualize this? So first thing is weight acting. Here he is able to rotate, weight acting vertically down direction, weight of the car కొద్ది వెయిట్ ఎక్కువ ఉంటుంది కాబట్టి క్యాపిటల్ MG పెట్టు. క్లియరా? అర్థమవుతుందా? సో సెంట్రిఫ్యూగల్ ఫోర్స్, హియర్ ఫ్రిక్షనల్ ఫోర్స్ ఆల్వేస్ యాక్ట్ opposite to the direction of motion. Frictional force is able to slip down, that is the frictional force. Now tell me, normal reaction always act perpendicular to the surface. At every point of contact, two normal reactions will be acting. Here radial acceleration towards the center of circular motion, V² by R centrifugal force always act opposite to the direction, mv² by R centrifugal force. Same story here also, same story. What is the normal reaction? Tell me. Centrifugal force, sum of the right force equal to left forces, n equal to how much? mv² by R. Here sigma fx equal to 0. Result. What is the sigma fy? ఇక్కడ మనము ఫ్రిక్షన్ కండిషన్ అప్లై చేయాలి. ఫ్రిక్షనల్ ఫోర్స్, వాట్ ఎవర్ ద ఫ్రిక్షనల్ ఫోర్స్ is obtained, sigma fy equal to 0, then frictional force equal to how much? mg. Frictional force equal to how much? mg. What is the limiting friction condition? Limiting friction condition. Whatever the frictional force, frictional force should not be more than FF maxima. That means FF, this is what? This is frictional force. This is FF maximum. What is the FF maximum? What is the FF maximum? Mu n. Maximum frictional force equal to how much? Mu n. So whatever the frictional force here must be less than or equal to mu n. What is frictional force is obtained here? mg. What is the normal reaction obtained here? mv square by r. mv square by r. mv square by r. m gets cancelled out. Then what is obtained? rg. rg less than or equal to mu into v square. Mu into v square. Clear? So v square rg by mu. rg by mu less than or equal to v square. Then v equal to how much? rg by mu. V should be greater than or equal to square root of rg by mu. So v greater than or equal to square root of rg by mu. Clear? What is the minimum is obtained here? What is the minimum velocity? What is the minimum velocity has to maintain? Square root of rg by mu. Square root of rg by mu. This is the minimum velocity has to maintain in order to avoid the slipping. Minimum velocity we need to maintain. Okay na? In order to avoid the slipping. This is all about some funda related to dynamics in circular motion.